So today we're going to be looking at rewriting linear equations because all linear equations can be written in the form y equals mx plus b, but they're not always given in the form y equals mx plus b. So for example, this equation right here, this is a linear equation, but it's not written in the form that we're familiar with. So we need to rewrite it so that way we can easily identify our slope and our y-intercept. So before we get into that, I wrote down a few steps. So I would suggest pausing the video and writing down the steps, and I'll kind of incorporate the steps into how I solve each of these problems later. But the steps for solving for y, first you would reorder, and I would put your y first, or whatever term has your y variable in it, I would put that as your first term in your equation, or all the way to the left. Then I would rewrite any subtraction using addition, just because addition is easier to work with. Recall your order of operations, PEMDAS. And then you want to reverse your order of operations in order to solve for y. And you have to remember some things about combining like terms in this step, and some other specific rules about, like combining like terms. What was the other one? Combining like terms. Possibly the distributive property. We're not going to get into that yet, but you might need that in the future. And then you would rearrange your equation into the form y equals mx plus b. So take a moment and write those down. So let's get started with this first example that we started with. So the first thing that I always do, and this may sound a little crazy, but I always kind of imagine that so first let's do our step one, which was to reorder. Okay, so let's reorder and put y first. So I'm going to rewrite this equation, and instead of, I know that there's an invisible plus here, right? So I'm going to rearrange this equation, and I'm going to rewrite this as negative 5y, right? Because this is really like plus negative 5, which is really my second step, which was to rewrite subtraction using addition. So I just did that and kind of combined that. Plus x equals 5. So I put my y term first, because it'll help me realize what's happening to y first and what's happening second, because I kind of imagine my y like a battlefield. I kind of imagine whenever I'm solving an equation, I kind of imagine my y like a battlefield, right? So I write my y down, right? And I say, well, what's happening to my y first? And that's where recalling your order of operations comes in. What's happening to my y first? Well, the first thing that's happening to my y is we're multiplying it by negative 5. So I kind of draw like a little barrier, and I know that I'm multiplying my y by negative 5. That's the first barrier that's happening to my y, the variable that I want to solve for. We're multiplying it by negative 5, right? Because multiplication comes first. Then the next thing that's happening is I am adding x to whatever that is. Next thing you do is add x. So in order to undo that, I kind of imagine that I'm a person on the outside. These are all barriers. I'm a person on the outside, and I'm trying to get to my y, but I have these two barriers. I have this plus x and this multiplying by negative 5 before I can get to my y. So I need to, in order to get to my y, I need to break down this first barrier. So the first barrier is adding x. So in order to undo adding x, I need to subtract x from both sides of my equation. So minus x, right? From both sides of our equation. This turns into a 0 pair and disappears. On the right-hand side of our equation, we're left with 5 minus x. We can't combine those because they're not like terms, right? So our equation now is minus 5y, or negative 5 times y is equal to 5 minus y. So now we've broken down this wall. And now we're in here. So now the next wall we need to break down is multiplying by negative 5. In order to undo multiplying by negative 5, we have to use our inverse operations, right? And we need to divide both sides of our equation by negative 5. So this negative 5 over negative 5 turns into a 1 pair, because any number divided by itself turns into a 1. And now we're just left with 1y on our left-hand side. On our right-hand side, we can break this into two fractions. We have 5 over negative 5 minus y over negative 5. So 5 over negative 5 is negative 1. Let's just rewrite that, negative 1. Y, we can think of this as 1y, right? 1y, we can think of this as 1 over negative 5 times y. So we can move this y to the outside like that. Well, 1 over negative 5 is negative 1/5, and minus negative 1/5 will give us positive 1/5 y. So we're almost there. So now we've rearranged this. I'm sorry, where did I get y from? This should be x. Sorry. Change all my y's over here to x's. Okay, so we're almost there. So now we just want to rearrange this using the associative property of addition. Y is equal, so we want to take our slope part, right, our mx first, which was positive 1/5 x, and then this would be our y-intercept, minus 1. So this would be the equation of our line, and now it's a lot easier for us to see that our slope is 1/5, rise 1, run 5, and our y-intercept is negative 1. Sorry I messed up in the beginning, but let's try another example. So this one is a little bit tougher. So here our y term is already first, so we don't need to do that. We don't have any subtraction that we need to change into addition. This is already addition, but there's a couple of more steps, right? So I want to take my y again, and I want to imagine that it's a battlefield. So what is happening to my y first? So this is our y. The first thing happening to my y is we are multiplying it by 4. So the first barrier is multiplying by 4. The second step is we're going to take that, whatever we get after we multiply y by 4, and we're adding 5x to it. Plus 5x. Right? So in order to undo that, as a person standing on the outside trying to get to our y, right, we need to undo adding 5x first. So we need to subtract 5x from both sides of the equation. After we do that, we end up with 4y on the left-hand side. 5x minus 5x is a 0 pair, so it kind of disappears there. And on the right-hand side of our equation, we have negative 4 minus 5x. So we have destroyed this wall, and now we're in the second wall. We need to destroy this one. So we need to destroy multiplying by 4. In order to undo multiplying by 4, we need to divide both sides of our equation by 4. 4 over 4 is a 1 pair, so we're just left with y on the left-hand side. Again, we can break this into two different fractions. So we'd have negative 4 over 4 minus 5x over 4. Like that, right? So negative 4 over 4, oh, we got negative 1 again. So negative 1, and then again we can split this up into a fraction times our variable. So we can move this x to the outside here. So minus 5 over 4x. And now we want to rearrange our equation into y equals mx plus b form. That was step 5. So we could rewrite that as negative 5/4 x minus 1 as our final equation. So our slope would be negative 5/4, and our y-intercept would be negative 1. So we would go down 4, right 1, down 4, right 1 from our y-intercept point. So far we've had some pretty easy numbers. Let's take a look at this example. So again, our y term is first, so that's good. And I'm going to go ahead and do this without the visual of trying to break through barriers, just so you can see we can get through these pretty quickly. So the first thing that I want to do is get rid of this. So 2x term, or not get rid of it, but I want to move it to the other side so that way I can isolate y. So I'm going to subtract 2x from both sides of my equation. So we're left with 3y is equal to negative 15 minus 2x. Remember, this is a constant, this is a variable term. You can't combine them, okay? So this would not be like negative 17x. You can't combine them. This is a number. This is not a number. We don't know what number this is because we don't know what x is, okay? If we knew what x was, then we could, but we don't. Then we're going to divide both sides of our equation by 3 in order to isolate y and turn it into just 1y instead of 3y. Now we have y is equal to, and we have negative 15 over 3 minus 2x over 3. Well, negative 15 over 3, well, 15 over 3 is 5, so negative 15 over 3 is negative 5. Minus 2/3 x. And then we just want to rearrange this so that way our x term is first and our constant is second. Y is equal to negative 2/3 x minus 5. So our slope is 2/3 and our y-intercept is 5. Last example, number 4. I haven't used the color green yet, so let's do that. All right. So this one is, honestly, it looks a little bit more difficult because we got a negative number, we got some minuses, but really there's only one thing happening to our variable. So if we're looking to solve for y, there's only one thing happening to it. The only thing that's happening to y is that we're multiplying it by negative 3. So in order to undo negative 3, we're going to divide both sides of our equation, the whole thing, by negative 3. So that way that turns into a 1. So we're left with y, and we have y isolated. We're going to split this into two fractions again. So 2x over negative 3 minus 12 over negative 3. So I'm going to just go ahead and move this x to the outside of my fraction. And the reason that you can do that is because x we can still write as like x over 1. So this is really like 2 over negative 3 times x over 1. So that's why you can take the x out. I'm sorry, now I lost my place. So positive 2 over negative 3 is negative 2/3. As long as one of the numbers is negative, then the whole fraction is negative. If both numbers are positive or both numbers are negative, then the whole fraction is positive. Right? So using that concept here, we have a positive 12 over negative 3. That means that this whole fraction is negative. This is negative 12 over 3. So negative 12 thirds, right? But 12 over 3 is 4, so that would make this negative 4. And now we have a double negative here. So I'm going to rewrite that one more time. Negative 2/3 x plus 4. So we know we have a negative slope, negative 2/3 slope, and a positive y-intercept at positive 4. So we could always plot our y-intercept at 4 and go down 2, right 3, down 2, right 3. We could also just go up 2, left 3, up 2, left 3, right? And just keep plotting those points to make our line.